we're just going to swap over to the slide deck. So now that we have the slides back up and I'm waiting for my laptop to restart, I can go into the talk and hopefully I can figure out which way. There we go. So these are anime GIFs, but they got converted to PDFs, so just imagine that pug's playing with something. So just we already kind of went into my bio, but I do application security for financial companies. That might change to be announced. I sort of have had a fascination with Microsoft provided languages for a long time. The first ever application I wrote was in QBasic in Windows 3.11. And I think it sort of, made me the person I am today. Yeah, QBasic, it's great. I also do security reactions Tumblr. That's something that some people know me for. And I'm also a little, whoa. Cool. Anyway, so why .NET? Like, why am I doing a talk about .NET, reverse engineering, exploitation? Well, people kind of had this. People have a perception of languages that are, managed, right? They don't really approach these languages the same way that they would approach, binary reversing of like an application written in C, C++. There's a different way to do this thing, and also there are different classes of bugs. You're not going to deal with memory corruption so much as you're going to deal with other types of bugs, like issues in reflection, issues in object deserialization, and so on. So, we all know that Java, or .NET is sort of Microsoft's kind of competitor to Java, sort of their response to Java. And we know that Java has just a couple problems. So, why not, take a focus on .NET? And, there are bugs in every language. I don't think I need to say that, right? I stole this from Veracode, but you can just see that, Java, .NET, they're kind of neck and neck. When you think about .NET applications, a lot of people just think of, they think of web stuff, right? They think of C#, VB.NET. But you can also write desktop applications in it. There are a lot of drivers that are written in C#. There are a lot of installers that are written in C#, for example. But in order for us to really understand how to look at .NET, we have to understand how it does, what makes it sort of special. And so the underlying thing about .NET is this thing called the Common Language Infrastructure, in which whatever source code you write in, as long as it is a .NET supported source code, you could use VB, you could use C#. There are some people who use F#. I don't know. I think I met with one of them once. I don't believe he was I think he was like a reptilian or something. I don't believe that is. But regardless of what you write it in, during compile time, it's when you compile it in Visual Studio or whatnot, it's going to be converted in something called CIL, which is your bytecode, Common Intermediary Language. And we're going to be looking at what CIL looks like in a few slides. The Common Language Runtime will convert that into native code at runtime. So it's sort of a just-in-time compilation. That is not true for everything. In some assemblies, such as the ones that are part of the .NET framework, such as MS Corelib, anything that you're sort of importing from .NET, those are actually pre-compiled into native code for efficiency reasons. I'll get into later why it's important to know that. Okay, so this is what Common Intermediary Language looks like. I wrote this little, just a little, almost like a Hello World Windows form application where you launch the app, the little button comes up, you click on the button, it shows this message. This is what it looks like in CIL. Some people compare it, they say it looks like assembly. I think that's sort of mean to say about assembly. But you see that it's loading a string. It's calling this show string function. It's doing a pop and then it's returning, right? So if you can read assembly, it shouldn't be too hard to figure out this. It's very well documented on Microsoft's site. If we want to reverse engineer a .NET executable or a DLL or whatnot, whatever, we have to first understand what the .NET PE file format looks like. There is a lot of information. You will find a wealth of information in the PE format. It is basically everything that you need to know about the application. This is what makes tools like Reflector work so well, why it's so easy to sort of decompile non-obfuscated code in .NET applications, just because there's so much information in PE, and I don't want to spend a lot of time on it, but this is just some of the stuff that you'll see, like there are some metadata strings. It's going to give you all the strings embedded in the source if you look in the user string heap. You're going to get all your information about your namespace, your types, your member names if you look in the strings stream. Okay? You're going to get types, methods, fields, properties, and events if you look in the metadata stream. The GUID is a unique identifier just so that you know that the assembly you're calling is the one that you meant to call. And then there's a binary data heap, which has things like method signatures and instantiations. Okay? So just going into the #tilde stream, you've got things like type definition, field definition, all the stuff I said before. Property definition. This is a lot of information. I mean, I'm not going to read the slide aloud to you, but just note that there's a lot of information, and it's very easy to access. If there's a tool that I like to use for this, and you can actually write your own if you want to get down and dirty and really learn how to parse the PE file format. It's not impossible to do. There are tools. Somebody wrote a tool written in Python a while ago. I don't think it's current anymore but just to say it's possible. I use a tool called CFF Explorer. I like it because it also comes with another app, the icon's a taco, and I really like tacos. Anyway, so this is just to show you the application that I just showed you before with the button one click. You know, you can see a lot of information. You can see the label that I give the button. You can see all of that information that I talked about before. You see the module type def. It's all in nice little file folder format that we're very familiar with using, right? Just to show you what the strings table looks like, and this is just in a hex editor. It's all in strings, and you can see some things that you might recognize. Windows.form, iContainer, things about reflection, okay? Those are all of it. That's your strings table, right? It's in plain text. It's not hard to find this information out, given you know what you're looking for. What are we probably looking for? Probably looking for bugs. Might not be. There's other reasons to reverse engineer things, right? Maybe you just want to figure out what somebody's doing. Maybe you are a person that likes to crack software. Don't do that. It's unethical. So one of the things, you know, this obviously will freak some people out, people who are worried about intellectual property. And so because it is so easy to take a .NET assembly and convert it back to, let's say, C# or VB, we have things that are obfuscators, right? Things that will encrypt your strings so you can't really understand what the original string value was, or variable name was. You can merge dependencies together, makes it a little bit harder. Usually that's just for portability, but it also makes it a little bit harder to do. I'm going to get into how you can kind of get around this. I'm not going to go into how to actually defeat specific kinds of obfuscation because there's just so many, but there are plenty of tools out there that can beat it. Most of the time, you'll be able to find something that will de-obfuscate it. You do lose a little bit of information, right? If your strings have been changed to generic blah values, you're not going to be able to get those back. So you don't know if this variable used to be user password. It's just going to be something like AAA. Okay. Other things you can do, rename symbols to something unprintable. So when you try to decompile your code, it doesn't look right. There is some stuff for tamper detection. Let's say I want to modify something and turn an innocent-looking app into a bad app. There are things that would detect the fact that you modified their assembly. And then resource encryption and assembly encryption, exactly what it sounds like. Just trying to convert it into, obviously, if you have an assembly that's encrypted, it's going to need to be decrypted so that other people can reference it, right? So just because something's encrypted, there's going to be a point where that decryption happens. If you can just hook into that, then you can get some of the original stuff back. So one of the things, I came up with this just because I wanted to show an example of what obfuscation looks like. And so this is Reflector, which is a very popular tool for decompiling and doing a little bit of reverse engineering on C# apps. And so this is what the obfuscated code looks like. And then when I de-obfuscate it, you get a bunch of information back. Reflector apparently has a sense of humor, because when I put reflector into reflector, I got this nice little reflector rickroll, and that was cute. So what can we do to, I've already touched on this a little bit, what can we do to overcome obfuscation? We can rename the symbols back into something that's a little bit more meaningful. Sorry, oh, it's just going forward. How do I go back? There we go, okay? You can decrypt, right? Just hook into whatever the decryption is being, whatever is performing the decryption. Remove any sort of proxy code jump classes. Sometimes they'll put like a whole bunch of buffer code in there, so it makes it just harder for you to find what you're looking for. If you have a source and you need to find the sink, instead of it being a direct call to your sink, maybe there are 5 little dummy functions in it that make this chain that you have to go through, just to make your life a little bit harder. Oh, now I don't know how buttons work. There's this other thing I want to talk about briefly, because when you get into modifying .NET assemblies, or you byte patching them, and also because people think it's sort of a security feature, there is something called strong name signing, where you provide a cryptographic hash to the assembly. It is supposed to guarantee name uniqueness. Obviously, the hash should be different. Even you have something called foo.dll, somebody else makes a foo.dll. That's a way to make sure you're referencing the right one. Also protect version lineage. Make sure you're using the version that you intend to use, not some old and busted one. And also to provide a strong integrity check. So that's the thing, going back to tamper detection. Well, if I can just check the hash, then if somebody's mucking around with this, that's, don't use it. So I just took this from MSDN, and I will just read this to you. This is their documentation about strong name signing. The presence of the attribute, meaning the strong name signature, does not necessarily mean that strong name validation takes place. In common full trust scenarios, meaning an application running on your desktop, the attribute is never considered because strong name signatures are never validated. Good job, Microsoft. No, I mean, it makes sense why they do that. What's the common maxim is like, if your desktop's owned, everything's owned anyway. So full trust scenario is your desktop. It makes a little bit more sense in, let's say, a hosted environment where you're going to have various trust levels between different applications. So I'm going to stop now for a second. I just want to, spin up my virtual machine for the demo that I'm going to do in a little bit. But I think it's important. I'm going to go into 2 things. I'm just going to go into a specific .NET vulnerability. I want this talk to be more about the reverse engineering side of it, because obviously you need to know, you need to know what you're looking for, but then you need to know how to look. And so I'm going to show you what you're looking for, and then I'm just going to go into a little bit of sort of end-to-end doing some reverse engineering, and just to figure out the functionality of something that hopefully you'll find interesting as well. And so let me just I just want to pull up my notes so that I don't get befuddled, and so that I speak about this in a way that will make sense to someone who might be uninitiated with vulnerabilities. So as I'm doing this, I'm just going to talk a little bit about it, but there we go. Okay. So I'm going to talk about, there's a couple of different types of vulnerabilities. The one I'm talking about, and I chose it because I just think it's really cute. This was not discovered by me. This is discovered by James Forshaw, who is basically my god in terms of .NET exploitation. He finds all the .NET bugs. They're always great. He gave a talk 2 years ago, or Black Hat 2012, about serialization vulnerabilities in .NET. He talks about serialization vulnerabilities in managed languages. So he's not just .NET. He's just really good at all managed languages. This bug is something that's failure to properly check objects using reflection. And I'll go into a little bit of what that means, but he calls it an anonymous method injection vulnerability. Basically, you're going to use this for privilege escalation. This is not, end-to-end compromise. This is, you are running, let's say, a piece of untrusted code, and you want to make it full trust. Okay? It's called the trusted chain learning attack for that exact reason, because you're starting out untrusted and you're going to basically hop up the privilege chain, and I'll explain how that works in .NET. But you're going to hop up that chain, just going from untrusted to maybe middle trust to going to full trust. And so he calls it a trusted chain attack. Some people also call it a learning attack. And the reason I like this bug is because the issue is in security exception. The thing that gets thrown when you're trying to gain access to something that you don't have privilege for. I just thought that, I don't know if irony is the best word for it, but maybe Alanis Morissette version of irony. So before I get into the actual bug, let's just talk a little bit about the .NET security model and how it works. Access rights are determined by a couple things. Permissions, which is set by the app domain. If you're on a desktop, you're probably going to be in a full trust situation because you don't have a concept. You usually have a concept of app domains for desktop applications. In a hosted environment, you're usually going to set up an app domain whenever you deploy an application. There's also this concept of transparency that was first introduced in Silverlight, but it is now in place in all hosted environments in .NET 4. You can roll back to the old security model in .NET 4 if you want to for backwards compatibility, but this is what you would see unless somebody decided to do that. Okay? Like I said, all desktop applications are going to be full trust unless somebody deliberately sandboxes that. The likelihood of someone taking the time to do that, probably pretty low. I mean, Silverlight is sandboxed for obvious reasons. Most people don't take that much care. So in the sandbox environment, there's something that enforces constraints that's called code access security. Most code is going to run with some level of partial trust. You can have full trust, but there's also another variety of trust levels: high, medium, low, and minimal. You can also have custom permission sets. What happens when code requests a protected operation? It's going to make a demand for that access, and you'll see this later, how that code actually works. What happens is the framework is going to walk the execution stack, checking permissions against every module in the chain. And it's going to throw that security exception that we talked about before, where the bug lives, and block if the stack frame doesn't have the right permissioning. Okay? Like I said, code in the global assembly cache, which is your MS Core lib, your .NET, awesome thing, system dot whatever thing, Windows form. Things that are in the global assembly cache, your little treasure chest of Microsoft modules, always runs full trust. That's important to know for later. So this is how it works. This is just a little diagram. So if you are requesting this, here. Let's say assembly A4 is going to check the grant set. You're going to check the grant set for assembly A4, for A3, for A2, and so on. They're going to have their own set of permissions. You're going to basically walk up this, make sure that each one has the correct level of permissions. Okay? These are some of the things that are available for a medium trust .NET sandbox. You're not allowed to do a lot of things. You can't muck with the registry. You can't really do any reflection. You can't do anything, muck with event logs. Can't call unmanaged code. And what you can do, but it's restricted, you have a limited amount of file operations you can do. You can usually write some subset of files, read some subset of files, but not read the whole file system. And you also have permission to do certain web functionality. Now this got a little, yeah, it's okay. It's a little hard to see, but this is how security transparency works. You basically have 3 buckets that your code would live in. There's critical code. In the middle, there's transparent code, which is the lowest level, and then in the middle is safe critical. Transparent code can only call safe critical code in itself. Safe critical code can call transparent and critical code in itself. And critical code can call everything. I'm sorry, safe critical can call critical and itself. Critical can call everything. Okay? This is enforced in the just-in-time compiler. That makes sense when I said before that well, it makes sense when I said GAC is always full trust because GAC is pre-compiled. The just-in-time compiler is not going to come into play there. Okay? So let's talk about security exception. How does it work? Okay? When you create a instance of security exception, let me see how to explain this well, okay? Basically what happens is a new instance of this class is going to occur for an exception caused by a deny, okay? So you make a demand for something you want. If you don't have the permission to get it, it's going to call a deny, throw a security exception. These are the parameters that would come out of a security exception. The error message that you get, the thing that you were denied from having, the permission set, and the method that encountered the exception. Okay. There's also the permission that that was demanded for, and there is also passes an iPermission object that identifies the permission that fails. So you can maybe explore that a little bit more. Here's the bug. So this is the code for a security exception. You see all the little parameters that I talked about before. Now, does anyone know the difference? Everyone here know the difference between a method and a field? Okay, because Microsoft kind of forgot. This assignment might seem to be just a field assignment, but demanded is actually running as a method. That means additional code is going to get executed when you do this assert. So let's go and see what's in, oh, I'm clicking the wrong thing. Let's go and see what's in demanded. Okay? So it's basically creating an XML object. It is converting the security object to an XML string, taking in the value, and then assigning it to mdemanded. So this is the code for the XML conversion, and I won't go into it too much, but you should just know that this value is array list. Array list is something we can create, something we can manipulate. This code runs with full trust. There's a possibility for an accepted chain here. Or I'm sorry, a trusted chain here. So here's the bug. This is how we exploit this. And it's actually pretty simple. I mean, I'm just throwing process. I'm creating a new security element, right? I am creating a new expression, and it's basically going to call process start, okay? If I just run this normally, it's just going to run with my trust set, right? It's not going to run with full trust. I'm creating a new list view, and then I am putting it into virtual mode. How to explain why virtual mode? That means it's going to be generated on demand. That means it's going to occur in the JIT. We want that to happen because we want security exception to throw. We are going to add E, okay? E compile just means basically run it. We're going to add it to the list view item. And then we are going to just modify the size and call this on array list. Remember, array list is basically we're just wrapping it in a couple layers, right? We're making a list view. We're putting it in an array list. Remember, array list is going to get evaluated back. Oh, I'm going the wrong way. What the hell? Oh, is it this one? Nope. How do I? I'm clicking every single different button. Wait. Oh. There we go. Okay, so remember this is an array list. When security element does its conversion, it's going to take our array list and then it's going to perform the execution. It's really a little hard to understand, but just sort of think of it as, kind of like a Kinder Egg, right? You got the foil, and then you got the nice chocolate, and then you got the little plastic egg on the inside, and then you've got a toy, and you eat the toy, and then you choke. So now that I've talked about, what a bug sort of looks like, and this is supposed to be hard. Finding trusted chains and figuring out whether they're exploitable or not is hard. It takes a lot of searching, right? So you need to know how to search. So hopefully this will show you how to do that. I decided to reverse reflector. I'm going to use reflector to reverse reflector because I heard you like reflector. The goal for this is to add new functionality to an existing binary, the existing binary being reflector. Okay? We need to I'm going to add a little icon to the reflector toolbar and launch some new functionality, code that didn't exist in a reflector before. Okay? And then I'll get into why that's sort of interesting and why that's fun, what you can do with that. So basically, I just need to figure out where the icons are made, put my own in there, locate the event handler for when you click on the icon, and make it launch my code. I don't want to write all of this code inside there, so what I'm going to do is have it call a DLL that is my DLL, something I made. So we're basically getting an application to call code that it has nothing to do with. Oh, I already talked about this. That's old. Anyway, so first thing I want to do, find out where those buttons live. What's an easy way to do that? Just look at the little mouse over label, right? It makes this nice little string, so it's probably going to be pretty unique in the code, right? So I use this thing called code search. The native search functionality in Reflector, pretty dicey. This is actually really good. Takes a little while to run, but there I go. I see that it's in class 269.method, and you can see something that looks like a command bar. All right, great. And there you can see that these methods probably weren't called this. They probably weren't so insane as to name their classes class 269, 270. This is a sort of side effect of having obfuscated code that I've de-obfuscated, okay? Reflector uses its own obfuscation product, which is great because they invented a tool to decompile code, and then they give you, so they made the disease, or they contributed to the disease, and then they give you the cure, which is their obfuscation product. So that's great. I like that. Anyway, here we can see where the toolbar is set up, and it's very easy. This is where we might assign some keys. This is where the label is, and here we can see what looks like where the, well, here's the toolbar. This is probably something having to do with a function. And this string is a little interesting too. So let's find out what's going on there. But first, while we're in here, let's just add a new icon. I'm using something called Reflexel. It allows you to put IL directly in here. The question people always ask me, why are you doing this? Why aren't you just decompiling it back into C#, putting it into Visual Studio, just modifying the C#, and then recompiling. It's sort of like taking a person apart, organ by organ, and then trying to put them back together. You have all the parts, but they're probably not going to be alive after that. And that's pretty much what happens when you try to take a complicated program, decompile it, and put it back. Something gets lost in translation. It doesn't really work. So instead of trying to overcome a whole bunch of different resolution conflicts, I just decided to inject IL. It's sort of like doing it in a text editor, but this is just a tool that makes it easier. So what I'm doing is just adding a new method reference. I'm basically just writing the same kind of IL that I did before, okay? And then I'm calling this function, getNian, which is going to invoke my new functionality, okay? You should learn IL. It really isn't that hard. If you want to learn, the easiest way is write a bunch of C# applications, write a bunch of VB applications, and then put them in either there's IL view in Visual Studio, there's IL view in Reflector. Okay, it's a really easy way to figure out this is the code that I wrote, this is what it looks like in IL, and it's really not hard to figure out what you need to inject in there. So I'm just adding load string, I'm adding a call, I'm loading some arguments, and this is, what this is just putting a 0 on. That means I don't want any key assignments. If you remember before, we had all those methods that you have to, or all of those things you have to pass into the function. This is just what I'm putting them all in, putting them all on there, okay? So this is sort of what the IL code looks like in sort of an easier to read view, okay? So it's basically what I said before. I'm just adding all of the arguments to the function that's being called, and then adding a separator. This is, where am I? Loading argument, loading a string, loading my 0, loading another string, calling this class, okay, this is going to be the onClick functionality. Oh wait, no, that's the functionality to get the button. I should know that, system drawing image. That's the functionality to get the button. It's going to get my button. We'll figure out how to do that next. So I had to figure out how it was getting icons, right? It didn't really make any sense to me until I started mucking around the resources part of this application. So these are all some fun little things that the application needs for various reasons. One, they can be images, they can be strings, they can be encryption information, I don't know, whatever you need. This is where all the little toolbars are, right? So what I ended up happening, and it's just too much to get into, I found a function, it was just carving off 16 by 16 chunks of this. So all I need to do is add a new 16 by 16 chunk on the end, then slice that off, right? Just leveraging existing functionality instead of trying to make my own thing happen. Okay? So now I have to figure out how to get that little click to happen, get the click to call my code. And so I started to dig a little bit more, and I saw that this weird method 29 thing was happening. Doing a search for, let's say, application.openFile. That has something to do with what's getting executed, but it's a string. What the heck's up with that? Just doing a search for that, I find these two things. Execute and query status. I'm only going to go into execute because the two are almost identical, and they do pretty much the same thing. Here's what it looks like. Basically, just a dictionary of strings and a switch of which function to call, depending on which string you pass in. So that's simple enough. Just going to add my own string and add the function that I want to call. Okay. Now I have to make this function. How am I going to do that? So I'm going to just inject a method, the method that I want to call, the one that I talked about in the previous slide. I'm not going to go back a slide because I always fuck that up. Anyway, pardon my French. So I'm just adding, right now, I'm injecting a method. Before I was just adding IL instructions. You can inject an entire method, and then you can write the IL in that blank method. Okay? So here's the CIL for my new function. I just wrote this because I'm gangsta like that. Just like to write some IL. Here is the equivalent in C#. Okay? It's basically just calling something called her and show form on it. But where are these classes implemented? In my DLL. How do I get it in there? I just wrote it in Visual Studio, and I just pop it in there. So easy. Inject assembly reference, and there it is, derp. Okay, it's just going to reference derp.dll as long as it's in the same place as all the other references for this executable live. We're good. So can we switch back to my laptop for a second? And hopefully this will work. Demo is.
I hit it enough times to work there.
Okay, so here's Reflector. Here's my cute little new button. Yay! Okay, so this, I feel that just greatly enhances Reflector, and I hope they will consider adding it for permanently. But if they don't, then you can add your own button for whatever, just to cheer yourself up, because it is hard work, reversing all day. You need something to kind of brighten your mood. Okay, so I'm going to go into the last thing. I'm going to have to do 2 more swaps, if that's okay with you. So let's go back to the slide deck. I'm sorry. It's pretty. I would say it's worth it. I don't know. Maybe I'm. All right. I just want to make sure that it's here. Okay, it is good.
Preview, come on. So while we're waiting, where can we get these amazing sweaters?
Oh, H&M. They're $10. They're on sale. $10. Get them while they get them before they sell out, because obviously,
Costs a lot to be part of the Trippy Cat gang.
Yeah. There is an initiation. If you wear our colors without getting initiated into the gang, it's sort of like wearing a blue handkerchief and not being a Crip. So we will bust a cat. So now that we know how to modify, just put our own code in something, make it do stuff that wasn't really supposed to do, let's use that to rootkit.net. Post-exploitation, all right? So I've owned this. What are the advantages to doing this? A lot of things that check for malware and whatnot are going to assume that nobody mucked with the .NET framework. At least I've been told this. So, and it's also really fun to do to yourself when you're drunk, is to change the functionality of some function that you use a lot, and then the next day when you don't remember that you've done this and you're trying to get your code to work and it's doing something completely different, like popping up a button that says, "Ha ha, drunk Kelly got you again." I'm a very lonely person. So what are we going to do? We're going to modify a global assembly cache assembly to hook into functions we want to monitor, right? So let's say we want to collect passwords. Every time it runs, it does a password, Windows form password or something like that, or has a password box. Let's just grab that. Let's send it to our own server. Maybe whenever it writes to a log file, maybe that's something that's interesting. Every time it does a database insert, maybe we want to look at that. Whatever we want. So what do we got to do? We need to find out what we want to modify. We need to disable nggen. Nggen is the thing that automatically creates the native code for these, so that for efficiency reasons, we got to disable that just to make sure that it's not getting recompiled, the good one is not getting recompiled and overwriting ours. Then we got to delete out that native image so that we can put our own in there. And then we overwrite the assembly with our file. Okay? mscorelib.dll. For mine, I am just going to use system drawing, because I like to make funny POCs and not ones that would actually help you out in life. So it's really easy to do, and I know this sort of sounds like an advertisement for Reflector. There are other tools you can use that are free. Teleric's pretty good. This is just the tool that I'm used to using, so I apologize for that, but there are other tools that are just as good. Teleric is really great. They also, if you're actually doing C# coding, they have a lot of good tools for performance and hooking into things to kind of figure out what the hell's going on in your buggy ass code. It's really easy to do. If you Reflector has a browser for the global assembly cache, and so let's say I want to do system drawing. Okay, I just search for it, and it gives me both the 4.0 version and the 2 version. Very helpful. Tells me what the public key token is. Don't care. I'll tell you why later. And where they live in the file system, so that we can just locate them, overwrite them. Same thing if you have been reversing a program, it's going to pop up, automatically load those dependencies into Reflector for you. So usually you're 100% of the time going to see mscorelib get popped in there, and then you can just see where it lives down there. Okay, so now that we know where this lives, we can grab it and start to muck around with it. I just decided to muck around with system drawing image. This is what it looks like. So let's say we want to load a nice little picture into our, I just lost my thought. How did you do that? It's a magic trick. Okay, I'm sorry. Let's say we have a Windows Form application. We want to put some cool little flashy image in there. A logo or something is pretty common. Spoilers. What is it going to do? Let's say we just want to pass in like a file location. We're not going to put it in our resources. We're just going to pass it in the file location. So just going to take that string, do some stuff on it. Determine the file exists, and then do some other calls to load it into the Windows form. So I just took all of the references to that string and deleted them and added a hard-coded reference to a string, because I'm not nice. Now we got to reinstall it into the GAC. Like I said before, nggen precompiles assemblies. Let's turn that off. That's how you do it. Just and say, okay, let's say we're modifying mscorelib. Just say uninstall it, and it's like, okay. And then we want to get rid of the native image, right? So we just remove. This is basically a folder. Everything lives in something that's Windows assembly, native images, and like some version string out here. So let's just delete this mscorelib folder out of nggen, or yeah, out of the native image folder. Okay. And this is an anime GIF of him talking the football. But now I just need to switch back to show you how this how this works. Zach. Okay. So my Windows Form application on my non-mucked with, I wasn't drunk here, looks like a cat. And then if I just go into here, my little VM with the tampered version, I'm just going to run this. I don't want to do any tricks. I'm just going to, it's loading, it's referencing the same image as that little cat one, but I'm just going to, I'm sorry that I should have opened this before, but my computer crashed. Let's run it in here with our modified environment. Oh, dick butt. So that's that. Obviously, that's just, I'm just going to see what my slides look like so you don't have to switch them back again. What's some useful assemblies that maybe we might want to look at? MS Core Lib is obviously one. System Windows Form, so you can just capture you know, any sort of user, well, that's a function, yeah, there is input functionality in there. So System Data is great. That's all the database connection logic. Obviously, that's pretty good. And System Web has, you know, all your HTTP data. You want to get some sessions or something, it's probably going to be in there. The next slide is just references, but I get most of this stuff off of MSDN, to be honest with you. They have everything really well documented, but you just need to know how to search for it in Google. I'm sorry, Microsoft person, but thing is, like, it's really good. I hear it's really good for porn. I don't know. You know, they don't know how to roll. But these are the tools I use as well, okay? Anatomy of a .NET assembly basically, you know, is a great tutorial for just going through this in way more detail than I did here. I also have this up on my blog. My blog's juked-micronics.com. If anyone gets that reference, I will buy you a free beer. Juked, J-U-K-T-Micronics, M-I-C-R-O-N-I-C-S.com. It's a reference to something, and I even got a mention in a book. As a woman who works in security, I'm famous. CFF Explorer is that thing that I use just to browse the PE. You get to get up a lot of interesting information. I just sort of just use it as a little, oh, this is okay. Is this what I want? Before I load it in Reflector and do any sort of, you know, surgery on it, worry about obfuscation, just make sure, just to muck around, get a good feeling that this is actually what I want to look at. ILSpy is a decompiler if you don't want to use Reflector. Redgate obviously makes all that wonderful stuff. Reflexel is the Redgate plugin for CIL injection that I use. And Code Search is the plugin that makes Redgate's search not so wimpy. Okay? You can use also DE4 deobfuscator. That's the one that I use. It works on pretty much everything except crypto obfuscate. For some reason, it does not like crypto obfuscate very much. So if you need to one of the questions is like, which obfuscation tool is the best? I would just say crypto obfuscate because they're all the same, but that's the one where the tool I like for deobfuscation doesn't work that well. I'll just put up my information here. And any questions if this ever goes up? Because it has an, I just want to give you at least one animated GIF for the evening. And it also just kind of brings the whole home. Okay, questions, comments, concerns? Beer? Yes?
If you wanted to reverse managed, or unmanaged or native code like C++ CLI, for example, is that similar to dealing with like MS Core Lib?
Sort of, but MS Core Lib, you can view it as like C#, and you can look at it in IL, right? You can actually reverse the native assembly if you want to, because that is native code. So if you want to, if you're comfortable with IDA, you want to load it in IDA, or what's the other one, Ollie, yeah, you can just look at the native code image. MS Core Lib DLL is the .NET pre-JITted code, so that's still managed code. But yeah, the native image is something you can just deal with the way you're used to dealing with all your other binaries. Sure. Okay, well, if there's something, I mean, you can always just grab me offline. I am easily harassable on Twitter and by email. And my blog is Truth Micronics, and I have updated it once in the past year. So it's going to be really easy to find that blog post. And yeah, so thank you for listening to me ramble about .NET. I have no idea how long I've been up here or what year it is anymore. So thank you very much.